Okay, so we will continue remaining part. Okay, so we were up to this. So we have drawn two stage. Okay, now for third stage they have given uh, draw the projections of the cone when front view of axis inclined 45 degree with HP and base is nearer to the observer. Okay, so first of all I will mark the axis. So these two lines are axis. So this I will make layer center. I will change its property and make it 0.25. Okay, so these two axes are there. I will name them. So this 3 and 7 are for generators. So there are generators and axis is overlapping there. So I will give some more name here. Suppose this is P. So this is P. This is also P. Okay, this is also P, and now I will project P. P will come here. Your P dash should be here in this numerical OP, O dash and P dash. So your P dash should be here. So there are 2 points here, O dash at the top and P dash at the bottom. So your P should come here. Okay, and the line O dash P dash will be your axis, but now there is a twist here. Okay, as we have seen yesterday's numerical, see here what I'm getting. See the length of this axis. This length of the axis is what 75 something. It has gone little ahead. Okay, the points are not so exact here. So these all points should be at this point. Even this. So length of the axis should be 75. Okay, it is little ahead because there was an error with the projection. This is 75. The same axis is here. If I take if I show dimension of this axis, so this is what 75 point something. It should be 75 here. Okay, so this axis is of the length 75. Okay, so this is true length, but if you measure the length of this axis, this is not a true length. This is 69.883. Why? Because this is front view of the axis. So this is axis true length. This is front view of the axis. As we have done in yesterday's numerical, if you see, as I said, this was pyramids numerical. This is top view of the axis of 60 true length, and this is what front view of the axis of length 56 point something. Okay, so that's why we have done this construction, because in that question they have said axis is inclined to the VP, axis inclined to the HP. Now for our this question, what they have said for the third stage, we will see. They have said when front view of axis inclined 45 degree with HP. So they have clearly said front view of axis inclined, and I am getting here front view of axis, so I will directly make it inclined 45 degree with the VP, 45 degree with the HP. Okay, inclination with HP means what? Inclination with HP means above XY. Okay, inclination with HP is above XY. So 45 degree with respect to HP is what? Your front view of axis. So this is very important when front view of axis is inclined. Okay, in previous numerical, yesterday's numerical, they have said axis was inclined. Okay, here front view of axis inclined, and I am getting here front view of axis. This is not the true length of axis. This is front view of axis. Okay. So I will mark here for your convenience. This is what TL of axis. Okay, so I will name this TL of axis. Okay, so this is true length of axis. Now this is what This is your front view of axis. Okay, so its length is lesser than 75. Okay, so this is front view of axis or EL of axis. Okay, so here it is directly given front view of axis, so I will make this directly inclined to the 45 degree. So what I can do, I can draw 45-degree line from this point. Okay, forget about that. Acha, they have said what? With HP and base is nearer to the observer. Acha, now when base is nearer to the observer, so this is its base and observer is here. So observer is looking from this direction. So the observer is here. Okay. So this is the direction of observer. So base should be there. Uh, so your 45 degree will be from here. Okay, in AutoCAD it is counting from this side. See, this angle is making 118, 127, 129. Okay, so this angle length will be anything, and I want 45 degree from here. From here, if I want 45 degrees, so 180 minus 45 is what? 135. So length is not so important. 135. So you are looking from here, so that's why, and it is nearer to the observer. So this base should be here. Okay, and I have to project this complete this cone here. Okay, so I will copy everything from here. So these all lines should be copied. Okay, and I'm pasting it somewhere here. I have one rotation command. You have to do with the rounder. Okay, I have points also. Okay, I have points also. So I will rotate this. You see this rotation command. Manually you have to do with the rounder. From rounder you have to make two arcs. If you want to locate any point, you have to make two arcs. So arrow enter is a command for rotation. This is my base point, and I'm going to use reference. So arrow. This is my base point and reference. So what I want, this line should be somewhere here. Okay, so I have rotated my cone with the base is nearer to the observer. Okay, so now project these points down. Ortho mode should be on. So this I will go number wise, so it will be easy. This is 1, then 2. 2 is intersection of the curves, then 3 has done, then 4. 4 and 3 are very close to each other, then 5, then 6, then 7. So you have to take projections from every point. 8. This is O. O will be on X line. Okay, so this projections you have taken from front view. Now